Okay, so today we're going to go over section 2.3, which is quadratic functions. And quadratic functions has equation. The equation of quadratic function is half x squared. That's how you know it's a quadratic function. We have x squared. So if the function has x squared, that means it's a quadratic. Now, there are two different forms. We have standard form, which looks like this, and vertex form, which looks like this. Now, the difference is the quadratic form is the same like when you solve quadratic equation. The form is you have x squared, you have x, you have number, where a, b, c are numbers, okay? And obviously a is not 0 because if a is 0, it's not going to be quadratic, right? Now, the vertex form, it's a different form which also have square. See, x inside, it's a squared, but you have number x next to x, x minus h, and number by itself. So this is just a little different form of the quadratic function. And what you need to do. In this vertex form, if you have the vertex form, it's easier to find the vertex. I'm going to explain what is vertex. So vertex is minimum or maximum point of the graph. So minimum maximum value is h and k. That's the vertex. Okay, it's called vertex. So I'm going to show the graph of quadratic, and we're going to talk about that more. So if a is positive, a is the first number. So you have a here and you have a in front. So a is the number in front of the square. And if a is positive number, then the turning point or the vertex is minimum point. And if a is positive, the graph looks like this. This is the graph of quadratic function. So this is parabola. Parabola looks like this. And the vertex is this point down here. So the minimum point is called vertex. Okay, so this is how the graph looks like. And the graph continue up and up like this. It's open up, it's going all the way to infinity, up to infinity. And the minimum point is called vertex. And the vertex has coordinates h and k. And this is the graph when the parabola is open up, okay? Which means when the first number or the number in front of the square is positive number. Now, what's happened if the number in front is negative? So if the first number, a, is negative, then the parabola is going to be open upside down. It's going to look like this. I'm trying to make it like as curved as possible. So it's like this. It's going to be open down, all the way going to negative infinity. Okay, it's going all the way down. And can you guess where is the vertex? Where is the vertex?
Is it both of them?
In the top, over here. So this is the vertex. Okay, so in this case, when the parabola is open down, the vertex is the maximum point, right? Is the highest point on the graph. If the parabola is open up, then the vertex is the minimum point. Everybody see that? Okay. So now what you're going to do with the parabola? You have the graph. This is the graph of quadratic function. It doesn't matter which form you have. You have quadratic form or you have vertex form. Doesn't matter which one of those you have. It's easy to go from form to form, and I can show you how to do that also. Doesn't matter which form you're going to. The parabola can be open down or open up. Okay? And this is how you how you get the axis of symmetry. Axis of symmetry, it's obviously the graph, it's a symmetrical across this line of symmetry, right? So the axis of symmetry, it's x equals h. So the axis of symmetry goes through the x coordinate of the vertex. And this is the axis of symmetry for parabola up and down. So this is x equals h also. Okay, so the vertex has coordinates h and k, and I'm gonna write here is the vertex. So the vertex is the minimum or the maximum, and the vertex has coordinates h and k. Okay, so this is how the quadratic function looks like. Any questions so far?
No, ma'am.
No? Okay. Now, what you're going to do with quadratic function, we're going to find all these things. We're going to find domain, we're going to find the vertex, axis of symmetry, X-intercept, Y-intercept, maximum, minimum, and all of this. Okay? The domain, the range, the graph, we're going to do all of it. Okay? So I'm going to start with finding the domain. So domain is X. And the domain here for any quadratic function, doesn't matter what function you have, domain always is negative infinity and infinity. That's the domain always, okay? Always domain negative infinity, infinity, okay? Now, finding the vertex. So these are the two different ways. If you have vertex form, you're gonna just look at the number next to X. This number, opposite of it, because it's minus, we're gonna get opposite of this number. Opposite of the number next to X. And the same number in the end, same number here, because it's plus K. And that's your vertex. So the vertex is gonna be always H and K. If you have a vertex form, you're just gonna look at those numbers, nothing else. Looking at the numbers, get those numbers, that's your vertex, okay? Now, if the equation is given in quadratic form, if you have ax squared, bx, and c, then there is a formula to find the vertex, and the formula is h equals negative b over 2a. That's how you find the h, the first coordinate for the vertex. Finding k is whatever you get for h, you're gonna plug it into the function. You're gonna replace all the x's with whatever number you find for h. So the formula for k is f of h. We're gonna do this, we're gonna do examples, we're gonna calculate the vertex using the formula, and I'm gonna show you how to do that, but right now, just know that finding the vertex, if you have the vertex form, you're just gonna get the numbers from there. If you have standard form, you're gonna use the formula. Make sense? Any questions here? We're gonna do examples, so we're gonna see how that works exactly. Now, after you find your h and k, after you find the vertex, the axis of symmetry is gonna be the equation here. We have it here, x equals h. That's your equation, x equals h, okay? So we're gonna do example, we're gonna see how that works, okay? Then the next one is finding the x-intercepts. Finding the x-intercepts, we have to solve, so this is the way to find it. For x-intercept, the y coordinate is 0 always. So here we're gonna solve y equals 0. Or technically f of x equals 0, because that's how you get the equation. Let's write it f of x. F of x and y, that means the same if you remember from functions. We talk about functions. f of x is the same like y, right? So we're going to solve f of x equals 0, okay? We're going to solve the function equals 0. And that's how you're going to get the x-intercept. Now the y-intercept, you're going to plug it in all the x's. It's only one y-intercept. X, you're going to replace x with 0. And that's how you're going to find y. Okay? So I'm going to plug it in 0 for x. And then finding the maximum or minimum. So if here we're going to use this, if a is positive, then you're going to have what? Minimum, right? If a is negative, you're going to have maximum. We're just going to write, do you have maximum or do you have minimum? And you're just going to look at your equation. If your equation have positive number in front of x squared, then it's a minimum. If it's negative in front of the square, it's a maximum, okay? And then you're going to graph the function. We're going to do the graphs. And doing the graph is putting the vertex, putting the x-intercept and the y-intercept in the graph, and then connect the points to make this smooth curve going upside down or down up, doesn't matter which one you have. Okay? Then you're going to state the range. The range of the function is what is y. So here we have two cases. So if a is positive, the range is going to be y. Okay, here, listen. If a is positive, that means the graph is going up, right? So that means y is going to be greater or equal to k. That's what you write. That's your range. Y is greater than k. And if a is negative, the range is going to be y is less or equal k, because the graph is going down, right? So that's the range. And then the interval function increasing and decreasing, we're going to do that also in a minute. Okay? Again, you have greater than 0 or less than 0, depends which one you have. And the intervals are going to be from negative infinity to h, and also from h to infinity. You have two intervals where it's going to be increasing or decreasing, depends what you have. For increasing and decreasing, these are the intervals you're going to use. Depends, just looking at the graph, you can tell in the first interval increase and the other decrease or backwards, okay? And always increase, you're going to look increase. Increase is when you go like this, go up left to right. And decrease is when you go down left to right, okay? So this is pretty much the information we're going to use to do examples, okay? Any questions so far? We're going to follow all these steps. Any questions?
No, ma'am.
No, everybody good? Okay. So we're going to start with number 1, which is this one, okay? So we have, I'm just going to go back to see which steps you have to do, but you're going to start to do domain and vertex first. Okay, so let's find the domain. How you find domain? What is the domain?
Negative infinity, positive infinity.
That's it, yes. You don't do anything, just put negative infinity, infinity. Now, let's find the vertex is the next step. So finding the vertex is, I have to look at the points, because which form you have? Vertex form or standard form? This is vertex form, right? So if you have vertex form, you're going to look at the number next to x and the number in the end. That's how you find it. So, so the vertex is going to have two numbers, h and k. The first number is going to be opposite of which number? Opposite of positive 1, right? Opposite of the number next to x. So it's going to be opposite of 1 is going to be negative 1, right? And then the second number is going to be the same number in the end. Same as -3, yes? You got it? So we have parentheses square. See, this is what you have. You have the vertex form because you have something squared plus number in the end. It's a vertex form. It's not x squared x a number. So you have parentheses square plus number. So you get the opposite of the number next to x and the same number in the end. That's how you get the vertex. Okay? So that's it. And then you have to find axis of symmetry. So the vertex is -3 and I'm sorry, -1, -3. That's your vertex. Okay? So h in this case is -1 and k is -3. That's it. The next one we need to find is axis of symmetry. So axis of symmetry is going to be x equals h. That's the formula. Right? And in this case, h was -1. So I'm just going to have x equals -1. That's my answer. That's it. X equals -1. Okay, we got the axis of symmetry. Then axis of symmetry, then we have to find the x-intercepts. So let's find the x-intercept now. So finding the x-intercepts, the rule is we have to solve f of x equals 0. So that's what we need to solve. Okay, how are we going to solve that? We're just going to copy the function, which is, what is my function? X plus 1 squared minus 3 equals 0. We have to solve that. How are we solving that? We're going to get the square by itself, so I'm going to add 3 in both sides. And you're going to get x plus 1 squared. We're solving this quadratic equation equals 3. And then here we're going to take square root in both sides. So I'm going to do square root here and square root in 3. But when you do square root, you always have to put plus or minus. That's how you get the two answers, correct? That's what we did in before the spring break. So we're solving quadratic equation with square root property. So when you take square root and square cancel. So you have x plus 1 equals plus or minus square root of 3. Now square root of 3 is not perfect square. But because we're going to graph, let's write it like this and then we can go from there. We need to get x by itself, so we're going to subtract 1 in both sides. And that will give us x equals plus or minus 3, square root of 3, minus 1. And these are my x-intercepts. So I'm going to have two x-intercepts. And the points on the graph are going to be square root of 3 minus 1, comma 0. And the other point is going to be square root of 3 minus 1. I'm sorry, minus square root of 3 minus 1, comma 0. So these are my x-intercept. These are the 2 points I'm going to use, right? On the graph. Now, because I'm going to graph, probably it's a good idea to see what is that. What is square root of 3 minus 1? So I'm going to kind of round the points to see. So I'm going to take, so in the calculator, you can do square root of 3, which is 1.73, and so on. And I'm going to subtract 1. So this is going to be approximately, when I graph it, is going to be 0.73. Okay. And then when I do negative square root of 3, and then I do minus 1, it's going to give me, the other one is going to be approximately negative 2.73. So these are going to be the points I'm going to use on the graph. That's why I need both of those, okay? So this is where the graph is going to cross the x-axis. Okay? So that's how you find the x-intercepts. We found them. And then the next step is finding the y-intercept. So now we're going to find the y-intercept. And for the y-intercept, we're going to replace x with 0. So I'm going to follow the function. So my f of x or y is going to be, or you know what, let's write it down here so I have more room. So my y or f of x is going to be f of 0, which means replacing x with 0 in the function is going to be 0 plus 1 square minus 3. So we're replacing x with 0 in the function in the original equation. Replace x with 0. So what is that? 0 plus 1 is 1. 1 squared is 1 minus 3. What is 1 minus 3? Negative 2, right? So my y-intercept is going to be the point 0 and negative 2. That's the point. That's going to be the point on the graph. So I'm going to graph 0, negative 2 is my y-intercept. Everybody good so far?
Yes, ma'am.
Okay, so we have the x-intercept, we have the y-intercept. Now we're going to continue with, what is the next one? Maximum or minimum. So let's see where the parabola is open. We have, what is A? What is in front of the square? In front of the square is 1, right? Everybody see that 1 in front? It's 1 parenthesis. There is invisible 1. There is nothing in front of the square, in front of the parenthesis. So that means it's 1. So if I want to find is it maximum or minimum, I need to see what is A. So A is 1, and because A is positive number, that means A is positive, that means the parabola is going to look like this. It's going to be open upside down, right? Open up. And then the vertex point is down here is going to be a minimum point, right? So that's all what you need to analyze. You have to see how the parabola is open, up and down, depends which one is A. And then you can graph the graph to see how it's going to look like. And the vertex is going to be the lowest or the highest point, depends what you have. So in this case, my vertex is going to be the minimum point. Okay? And then here we have the next one is we need to graph it. So after the maximum, the minimum, the next one is the graphing the function. So we're going to graph it now. So when you graph it, you're going to use all the points. You're going to use everything you have in here. You have the vertex, x-intercept, y-intercept. We're going to graph it. And before I do that, I'm going to draw my coordinate system. So this is my x and y axes. The intercept of the origin 0, 0. And then I'm going to start with the vertex. So where is the vertex? The vertex is negative 1, negative 3. Negative 1, and you need to go negative 3. Okay, so this is negative 3 and negative 1. So this is my point. This is my vertex. Okay, then after that, I have to graph all the points I have. So the x-intercepts are 0.73, which is, if this is 1, 0.73 is going to be before that, right? And then negative 2 is going to be between negative 2 and negative 3. and it's gonna be, let's say here, before that. And also, so I have these 2 points. Let me actually use different color so I can see. So I have, this is my vertex. This is my X-intercepts. And also I have Y-intercept at -2, right? This is my Y-intercept. So what you're doing here, we're gonna connect those 3 or 4 points, and you're gonna make a smooth graph going up like this. So you're gonna curve at the vertex. You're gonna cross the x-axis at those 2 points. You're gonna cross the y-axis at that -2 point. And this is the graph. This is the vertex, -1, -3 is the vertex. And these are my x-intercept and the y-intercept. So this is how the graph is gonna look like. Everybody understand the graph? And what else we have to do? We have to find the range, and you have to find the increasing, decreasing intervals. So the range, if it's open up, the range is gonna be above the graph, right? Above the vertex is the graph. So it's gonna start from, it's gonna be y is greater or equal to -3. You can write it like this, or with interval notation is gonna start from -3 to infinity. That's how you write the range with interval notation. Okay, and I'm gonna put the interval notation here in the notes also. So y is greater than k, also you can write it like k to infinity, and y is less or equal k is gonna be from parentheses -infinity k. That's how you write the range with interval notation. Okay, and then we have to find the interval of increasing or decreasing. So looking at my graph.
So I'm sorry. So for the range, it would be -3, -infinity.
Positive, because you're going up.
Okay. And so why is the other y-intercept, why is that one not part of the range?
We're including the from the vertex to infinity, not the intercept.
Okay.
Okay, the range is from the vertex. See the graph, the range is looking at the graph. The graph is going from the vertex point.
Oh, I see it.
Way up.
I see it now.
Okay, okay.
Yep. Thank you.
Welcome. So now where the graph is increasing, where it's decreasing. Always when you look for that, look from left to right. So from the left side, if I need to graph the, if you need to graph the graph, draw the graph, from left to right, I'm gonna go in this side, I'm gonna draw down, right? Left to right. So in this case, in this side, the graph is decreasing. So it's gonna be from -infinity to this point, to -1. Okay? And the graph is increasing, going up left to right. So when you draw the graph from left to right, so from left to right, I'm gonna draw it this way, right? It's gonna go up, it's gonna increase. So the increasing part is gonna be from -1 to infinity. And always when you write the increasing and decreasing intervals, you always look for the x coordinates, because the x coordinates determine where the increasing and decreasing intervals are looking on the x-axis. So that's why using -1, not -3. So you're looking left to right, you're looking on the x-axis. Okay, everybody understand that? Okay, so this is what you're gonna do for all the steps, all the examples we're gonna do. We have to do all these steps, okay? Now, when you do your homework, it's gonna ask you to do different things, but here, if whatever they ask you, you have to just look at all these steps we have and just do exactly what they're asking you. Okay, but for the handout we're going to do all the steps. Okay? Okay, so we're going to do the same example, but we're going to do number 4, which is also in vertex form. And we're going to do the same steps. So we're going to start with the first step is finding the domain. So looking at my equation, it's in vertex form, but for domain, doesn't matter which form it is. If it's quadratic, domain is always negative infinity, positive infinity. That's the domain. Okay, after that, we have to find the vertex. So the vertex is going to be, we're going to look at the numbers next to x and the number by itself. So next to x, we have -1. We're going to get the opposite of this, right? And the number by itself, it's -1 also, but in this, it's going to be the same. Okay, so can you tell me what is my vertex?
1 and
1
1.
and -1.
1 and -1, that's right. Opposite of -1 is 1, and the same number is -1. So this is my vertex. And I'm going to also write down, so this is the vertex. I'm going to write down what is h and what is k, because that's what I'm going to need later on. So h is 1 and k is -1. Okay? Now, after we find that vertex, we're going to find axis of symmetry. What is the axis of symmetry? X equals what? X equals h is the formula. So it's going to be x equals 1. That's your axis of symmetry. So x equals 1 is the axis of symmetry. Okay? After that, we need to find the x-intercepts. So for x-intercept, we have to solve the function equals 0. So we need to solve negative x minus 1 squared minus 1 equals 0. This is what we have to solve, right? So how you solve it? I'm going to add 1 in both sides. And you're going to get negative x minus 1 squared equals 1. Then we want to get rid of this negative in front, so I'm going to divide by negative. Negative over negative is positive. And you're going to get x minus 1 squared equals -1. Then here we're going to take the square root to get x by itself, right? We're doing square root property again. So taking the square root in both sides, and also don't forget plus or minus in front to get the two answers. Now what's happened here is when you take square root, see the square root cancel the square, and you're going to get x minus 1 equals plus or minus. When you take square root of negative, this is not real. So that means, so square root of -1 or negative number is not real. And if you put it in the calculator, it's going to give you error. So square root of -1 is not real. So that means there are no x-intercepts. You can find x-intercepts, and which is okay. That means the graph is not crossing the x-axis. Okay? So x-intercept, there are no x-intercepts. You don't cross the x-axis, which is okay. Now let's find the y-intercept. For the y-intercept, we're going to replace x with 0, so it's going to be f of 0. So we have negative 0 minus 1 squared minus 1. So -1 squared is 1, so it's going to be -1 minus 1 is -2. Okay? So the y-intercept, the point on the y-axis, where you're going to cross the y-axis, is going to be x is 0, and -2 is the y. So this is my point. You're going to cross the y-axis at 0 and -2. Okay? So you have no x-intercepts. We have y-intercept is 0, -2. The vertex is 1 and -1. Okay? So far, so good. Then we have to do, let's see what else we have to do. After this, we have, where we are. We have x-intercept, y-intercept. Okay, we need to find maximum, minimum, and then graph. Okay, so let's do that. Maximum, minimum, and graph. Okay, so looking at my function, I need to find maximum and minimum. What do you think we have? What is A? Can you see the A? A is the number in front of the square. What is it? What you have in front of the parentheses?
-1.
-1, that's right. So A is -1, that's correct. And -1 is less than 0, it's negative number, right? And if it's negative number, that means the graph is gonna go down, it's gonna look like this. So if the graph is open upside down, the vertex is gonna be this point, right? And the vertex is gonna be the highest or the lowest point?
Highest point.
Highest, which means maximum point. That's right. Everybody understanding that? So in this case, you're going to have maximum. So the vertex is going to be the maximum point. Okay, then we have to graph it. So let's graph the graph. Let's do the graph now. So we're going to have the, let's see, we have no x-intercept and the 1, -1. So we're going to start with the x-axis and y-axis. And we're going to start graphing the points. Okay, so this is my x-axis and y-axis. So first we're going to start with vertex. Vertex was 1 and -1. So x is 1, y is -1. This is my vertex. Okay, I don't have x-intercept because you see the graph is going down. So from -1, 1, when you go down and you're crossing the y-axis at -2, obviously you're not going to cross the x-axis, right? And you're just going to make it symmetrical. So this is my graph. It's going down. You're not crossing the x-axis. You're crossing the y-axis at -2. And also you can graph the axis of symmetry. Axis of symmetry is going to go to the middle and it's going to go through, the equation is x equals 1, right? That's the equation. And x equals 1, it's a vertical line which going through 1. Okay, so this is the graph. We have the graph, the parabola is open upside down. We have the axis of symmetry also. The vertex is at 1 and -1. We can put that here, 1 and -1. And you're crossing the y-axis at -2. Okay, so that's the graph. Now we need to find also the range and increasing and decreasing. Range is going to be, because it's up and down, is going to be y is less or equal k, which is -1, right? And with intervals, it's going to be from negative infinity to negative 1. So that's the range. And then we're going to use the graph to find where it's increasing or decreasing. So the interval of decreasing and interval of increasing, where it is. So let's look at decreasing, where you graph the graph going down, left to right. So when you start from here, you're going to go up, right? And then you're going to go down. So this side is you're going to draw down. And this side is going to be described with 1 to going down, right, to infinity. We're looking at the x-axis, okay? So decreasing is going to be from 1 to infinity, and the increasing is going to be the other side. So increase is going up, is going to be from negative infinity to 1. Always when you write the intervals of increase and decrease, make sure you go look at the x-axis, the x-coordinates, okay? So these are the intervals of increasing and decreasing, and this is how you finish this problem, okay? Any questions?
Yeah, I think I got confused. In the increasing part is positive 1.
Yes.
Okay, thank you.
Yes, because when you do the intervals for increase and decrease, you're looking at the x-axis. So technically, from here to here, it's increasing. And then from 1 to infinity is decreasing. You're looking at
yeah,
the
it makes
coordinates.
sense. Now I get it. Thank you.
Yes. Okay. Any other questions? Okay, so that's how you graph and analyze a quadratic function when you have the function in the vertex form. Then the next examples we're going to do is when the function is given in standard form. Number 5 is standard form, and number 6 is also vertex form. Standard form, sorry, standard form. So we're going to do number 6. Okay, so we're going to start with number 6 and probably going to do another example also. So in number 6, we're going to do the same. We're going to do all the steps. So we're going to start with the domain. What is the domain? The same. It doesn't matter which form it is. Everything is the same, only finding the vertex is different, okay? Everything else stays the same. So the domain is negative infinity, infinity always. If it's quadratic, that's your domain. Okay, you don't do anything, just write domain, negative infinity, infinity. Okay, then you're going to start finding the vertex. So finding the vertex is the part which is a little different for the standard form equation. So finding the vertex, we're not gonna sorry, I need to plug my computer. The battery is going down. So finding the vertex, if we have the equation in standard form, is we're not just gonna look at the numbers there, finding h and k, we're gonna use the vertex formula, okay? And the vertex formula is h equals, I'm gonna write the formula. So the formula is h equals negative b over 2a. That's the formula for h. And k is f of h. I'm going to do both of those. These are the formulas. And this is how you do it. So looking at my equation, You know, when you have quadratic equation, remember a is in front of x squared, b is in front of x, c is the number by itself. So looking at my equation, can you tell me what is a? What is the number in front of x squared? It's invisible 1, right? Do you guys remember quadratic equation? In front of x squared is 1. What is b? B is in front of x. What you have in front of x? What is the number in front of x? Is 2. And what is c? We don't need c, but I'm going to write it. What is c? C is the number
4.
by itself. -4. All the numbers, they're going to go with the sign in front of them. Okay? So we have a, we have b, we have c. The same way you're solving quadratic equation with the formula. In front of x squared is a, in front of x is b, and the number with no x is c. Okay? And then we're going to get this a, b, and c, plug it in into the formula. So I have negative, b is 2 over 2 times a is 1. And you're going to simplify this, so that's -1. So h is -1. After you find h, we're going to find k. And you're finding k when you plug it in, whatever you find for h, which is -1, for each x. So it's going to be, you're going to replace x with -1 squared, plus you just follow the function, and you're going to plug it in. You're going to replace x with h, whatever you get. -1 is going to replace, so going to put -1 for each x. And then you're going to simplify this. So -1 squared is 1, minus 2, because 2 times -1 is -2, and then -4. So that's going to be -5. And that's my k. So my vertex is going to be h, which is -1 and -5. Okay? Everybody understand how we get that? So we are using the formula h equals and k equals. Okay? And then after you find the vertex, we're doing everything the same way from there. Axis of symmetry. What is the axis of symmetry? X equals h, right? Axis of symmetry is x equals h. In this case, what is h? -1. So the equation of axis of symmetry is going to be x equals -1. That's my axis of symmetry. Okay, then you're going to find the x-intercept and the y-intercept the same way. So finding the x-intercept first. Okay, finding the x-intercept is solving the equation x squared plus 2x minus 4 equals 0. Now this equation, you can solve it in different ways. You can solve it by quadratic formula, you can solve it by factoring, or you can go get the vertex form of the equation and solve it the same way we did it with the previous examples. Okay, and I'm going to show you how to get the vertex form. So this is standard form of the equation, right? Getting the vertex form, it's really easy if you have h and k. So the vertex form of the equation, it's really easy if you know h and k. So the formula is a, I'm going to write the formula, x minus h squared plus k, right? This is the formula. So now I know a, I know h, I know k. If I plug it in, I'm going to get the vertex form. Okay, what is A? A is 1. So I'm just going to rewrite the equation in the vertex form. So it's going to be 1 x minus h. What is h? Negative 1. Minus minus is plus 1 square plus k. What is k? Negative 5. And that's equals 0. So this equation, the vertex form of the equation and the standard form of equation, they're the same. So if I solve the first equation, I can solve the second equation also. So it doesn't matter which one is easier for you. Okay? You can solve the first one using quadratic formula, or you can solve the second one using the square root property, whatever it's easier for you. Okay? I just wanted to show you the vertex form. Okay, and I'm just going to solve it using the square root property. So I'm going to add 5 in both sides. And you're going to get x plus 1 square equals 5. This cancel, right? And then I'm going to take square root in both sides. And don't forget the plus or minus in front. And you're going to solve it from there. So we have the square root cancel the square. We have x plus 1 equals plus minus square root of 5. And then you're just going to subtract 1 in both sides. So this is your x equals. Okay? So x equals this. Okay, so the x-intercepts, I'm going to write the x-intercepts are going to be number comma 0, right? So it's going to be square root of 5 minus 1 comma 0 is the first point. And then square root of 5 plus 1, I'm sorry, minus minus. So it's going to be negative square root of 5 minus 1 comma 0. And these are my x-intercepts. And also I'm going to use the calculator to see exactly where I'm going to grab those 2 points, right? So the first point, when I do square root of 5, which is about 2 point something, 2.236 and so on. And when I subtract 1, it's going to be approximately about 1.24. Let's say 2.4. I'm going to round it like this. And the other one, when I make it negative square root of 5 and then minus 1 is going to be negative 3.24. So these are the points I'm going to graph on the graph. Make sense? Everybody understanding this? Any questions?
No, man.
No? Okay. So from here, after we find the x-intercept, we're going to find the y-intercept. We're going to the next step. The y-intercept is going to be when I replace x with 0, right? So I'm going to follow. In this case, it's easy to use. Sorry, what's happened? Okay. I'm going to use the original equation. The vertex, the standard form is easier to use. So I'm going to plug it. It's going to be f of 0. And I'm going to replace it. So it's going to be 0 square plus 2 times 0 minus 4, right? And then when I put the 0 inside, replace all the x's with 0. I mean, this is 0, this is 0. So it's going to be negative 4. Okay? So the y-intercept is going to be at negative 4. You're going to cross the y-axis at negative 4. And the point on the graph You need to write the coordinate is 0, -4. Okay? So that's it. Okay? So that's how you find the X-intercept, the Y-intercept. The next step is we need to graph everything. We need to put everything together on the graph. So we have, let's do the graph. X and Y. And we have 1, 2, 3, 4. Okay, so let's start with 1, 2, 3, 4, 5. Yeah. So let's start with the vertex. So vertex was -1, -5. Let's do that first. -1, -5. It's right in here. That's the vertex. Okay, then we have the y-intercepts at -4. And then we have 1 point something is my x-intercept, one of those. And the other one is -3 point. 1, 2, 3 point something, right? And then I'm going to grab the axis of symmetry also. So that way I have kind of to see where the graph is symmetrical around. And then you're just going to connect it. So it's going to be going through the vertex. Oh, sorry. Let's use the different color. So it's going to be from the vertex, crossing at the y-intercept and then crossing the x-intercept and going all the way up. And in the left side is going to be something like that, symmetrical. Okay? I mean, my scale is not quite right. That's why it's kind of a little crooked. But that's how the graph looks like, okay? So this is -5, I'm sorry, -4. And then you have at 1 point something, -3 point something, okay? So this is my graph. Now let's write the range and the increasing and decreasing. So what is the range? Now the graph is going up, or I forget the maximum minimum. So in this case, if the graph is going up, that means you have a minimum, right? It's a minimum point, the vertex. And the range is going to be from k, which is -5, all the way to infinity. The graph is going up. And we need to find where it's increasing and decreasing. So the graph is increasing. When you draw it left to right, it's going to be increasing here, right? You're drawing up here. And you're going drawing down here, left to right. So increasing is going to be from -1 to infinity. Is increasing. You're looking at the x-coordinate always when you write increasing, decreasing. And decreasing is in the other side, from -infinity to -1. Okay? So this is how you do questions where you have the function given in standard form. You do the same, the only difference is finding the vertex when you have to use the vertex formula. Okay? So that's how you do those. And I'm going to do, probably I'm going to do one more. And also I'm going to show you how to do some applications. We're going to do revenue and cost function like this. Okay? So you guys want to do one more? You want one more or are you good?
I think we're good.
You good? Okay. Let's just do one more with revenue and cost functions. Okay. So I'm going to do this one. So here we have the revenue and the cost functions are given. So I have revenue is the first one, C is the cost function. And we're talking about manufacturing components for washing machines. So these are the revenue and the cost functions. X is the number of components in millions. That's important. And the revenue and the cost function are in millions of dollars. Okay, so everything is in millions. And first one is how many components must be sold in order to company to break even. Break even when the revenue equals the cost. Okay. So here pretty much I'm gonna do this. I'm gonna just move this so I can, oh, I can move it. It's a PDF. Okay. So I'm just gonna do ABC down here. Okay. So I'm gonna write it here first. So finding the break even is when the revenue equals cost or when the profit equals 0, doesn't matter. But here you have to solve quadratic equation equals solve quadratic equation. We need to solve that equation, okay? Now find the profit is just subtract revenue minus cost, that's the formula. And if you need to find the maximum profit from the profit function, so using the profit function, you have to find the vertex. So the vertex is going to be the maximum. So here you have to find the vertex. Okay? So that's how you do that. And let's do it. So the first one I'm going to do is A. So you need to find the break even. The break even is solving revenue equals cost. So revenue, I'm going to multiply this first. I'm going to just do it together. So it's going to be 200x minus 4x squared. That's my revenue equals 160 plus 20x. Okay? And then I'm going to move everything in the same side. So I'm going to add 4x squared. This cancel. And I'm going to subtract 200x. So it's going to be equal 0, right? So when I combine those, I'm going to have 4x squared minus 200 minus 20 is 180x plus 160 equals 0. And you're going to solve this. Now looking at the numbers, all these numbers, looks like all of those numbers are divisible by 4, right? Is that correct? You can divide everything by 4. So I'm going to divide the equation by 4 so I can work with smaller numbers. So I'm going to get x squared minus 45x plus 40 equals 0, right? And then we're going to solve it. Even if you use the formula, it's going to be easier to solve, easier to factor out, right, and solve. So let's see, 40. Probably I'm going to use the formula here. I'm going to use the quadratic formula. So A is 1, B is negative 45, and C is 40. Even with the formula, is going to help me if I have small numbers, right? So I'm going to use the formula. The formula is negative B plus or minus square root B squared minus 4AC everything over 2A. And I'm going to plug it in. So I have negative B, which is negative 45, then negative 45 squared minus 4A and C over 2A. And then I'm going to simplify. So I'm going to have negative and negative, it's positive 45 plus or minus square root everything over 2. Okay, so now what is 45 square? It's 2025 minus 4 times 4 is 160, right? Minus 160 when you subtract is going to be 1865, and then I have to take square root of that. It's not perfect square, but I'm going to round it. So what I have so far is 45 plus or minus, did it say how to round it? To the nearest million, okay? So that means you have to round to the whole number, okay? So when I subtract 2025 minus 160 and take square root, it's going to be approximately 43. You round to the whole number, right? Divided by 2. And then from here, we're going to do positive and negative. So I'm going to do 45 plus 43 over 2. And that's going to be 45 plus 43 is going to be 88. Divided by 2 is 44. And the other one is 45 minus 43 over 2. So that's going to be what? 1, right? Which is 2 over 2 is 1, yeah. So these are the break even. 44 millions or 1 million. Okay? Everybody understand that? So that was A. That's how you find the break-even point. Then for B, you have to find the profit function. So profit function is revenue minus cost, right? I'm going to use different color here. So profit is revenue minus cost. So I'm going to copy the revenue, which is when I multiply 200, I'm going to go from here. 200x minus 4x squared, that's my revenue. So this is revenue minus, I need to copy the cost, which is 160 plus 20x, right? But because it's minus the whole function, it's good to put it in parentheses, okay? And then from here, we're going to distribute the negative, and we're going to get, I'm going to rewrite this. So we're going to combine those two. So it's going to be negative 4x squared plus 180x minus 160. So this is my profit function. Any questions? Everybody understand how to get the profit?
Yes, ma'am.
Okay, then you're going to go to C, the next one, which asks us to find the maximum. See, C says, find the maximum profit. How many components must be sold to achieve the maximum? So finding the vertex, that's what you need to find. And here we're going to use the vertex formula. So in this profit equation, A is -4 and B is 180. That's what I need to for the vertex, right? And I'm going to use the vertex formula. It's going to be -B over 2A. That's the formula. And it's going to be -180 over 2 times -4. And you're going to reduce that. So it's going to be 180 when I divide it by 8, because 2 times is going to be 22.5. Okay, let's see what it says. How many components? So they're gonna be sold 22.5 million components, right? That's how many they need to produce and sell to get a maximum profit, right? And now, what is the maximum profit? So finding the maximum profit is finding K. What that means, put 22.5 in the profit function. P of 22.5, right? So it's gonna be negative 4, 22.5 squared plus 180, 22.5 minus 160. When you do that, we're gonna find what is the maximum profit. And here I can use symbol up calculator. Let's use symbol up calculator. It's gonna be easier that way. So we're gonna plug it in. So it was negative 4, 22.5 squared. Oops. What was that? Negative 4 plus 180. We have plus 180, 22.5 minus 160, right? That's the formula. That's plug it in, and then it's gonna give me its. So the profit is gonna be. Oh, I forget the 180. That's why I'm like, why getting negative profit? Which is okay. We can get negative profit sometimes, but make sure you check it out. So 1865. And it's gonna be $1 million, right? We're talking about money here, right? Profit, it's a money amount. So it's gonna be $1,865 million. Okay, everybody understanding this? Okay, so that's how you do all the profit question. That's how you find break even. That's how you find the maximum profit and how many components you need to produce to get the maximum. Okay, so that's what you have for today.